All right, let's talk about AI. But forget everything you think you know about code and algorithms, just for a minute. What if instead we looked at it through the lens of physics?
I mean, seriously, what if the ideas inside an AI's mind actually had their own gravity? Imagine concepts literally bending the space around them, pulling other ideas closer, kind of like planets circling a star. Now, this might sound like science fiction, but stick with me. It's not just some cool metaphor. It's actually a really powerful way to understand how these advanced AIs are starting to see our world.
Okay, so to get our heads around this, we first need a map. But we're not talking about a map of roads and cities. No, this is a map of meaning itself, a place we can call semantic space, where literally every concept you can think of has its own unique address.
So, how does an AI even start to understand language? I mean, it can't just use a dictionary, right? That's way too black and white. It needs to get the vibe, the relationships, the subtle connections between words. And the way it does that is by plotting concepts onto this map, using a tool called an embedding.
So what on earth is an embedding? Well, you can think of it as a set of coordinates, just like GPS for an idea. In this giant, mind-bending, multi-dimensional space, things that are similar in meaning get placed close to each other, and things that are totally different, they get pushed way, way apart.
And it's actually super intuitive when you think about it. The location for king would be right next door to queen, right? They share all these ideas of royalty and power. But the location for, say, cabbage, that's going to be in a whole other solar system on this map. Makes sense. But this is where things start to get really wild.
See, some words aren't just little pins on the map. Some words are heavy. They're so packed with potential meaning that they start to act like massive celestial bodies, literally warping the fabric of the semantic space around them.
This quote really hits the nail on the head. A word isn't one fixed point. It's more like a cloud of potential. It's a superposition of all its possible meanings, all just hanging out in the air, waiting for the right context to snap one of them into focus.
Let's take a classic example, the word bank. This word has some serious semantic weight. It's got this powerful gravitational pull on two completely different ideas: money from the world of finance and river from the natural world. So on our map, bank is sitting right in the middle, tugging on both of those concepts at the same time.
And this is the really cool part. This mass literally curves the space of meaning around it. This is what we call semantic gravitational lensing. Just like a huge star can bend the path of light, and an ambiguous word like bank bends the pathways of meaning. Any other idea that gets too close is going to get its trajectory warped by this dual gravity.
So how does the AI figure out which bank we're talking about? Well, it all comes down to context. The second you say, the boat reached the river bank, everything changes. The word boat brings in its own gravity. It pulls the meaning toward river and shoves money out of the way. And just like that, poof, the ambiguity collapses. The meaning locks into place.
Okay, so we've got this curved map of words. That's pretty amazing. But let's be real, our world is so much more than just words. To really get a handle on reality, the AI needs to add more dimensions to its understanding.
Think about it. The world isn't flat, and it's not just text. It's sound, it's sight, it's motion, it's the constant flow of time. For an AI to truly understand what's going on, it can't just read the script. It has to watch the whole movie.
And each one of these things adds a whole new layer, a new dimension of meaning. You've got text and language, of course, but then you add audio. That gives you tone, emotion. You add video and images for visual context. You add spatial location to know where things are. And then you add the temporal flow, the passage of time, to know when.
So when you start stacking all of these layers on top of each other, text, audio, video, location, time, you don't have a flat map anymore. What you have is more like a hologram, a rich, dynamic, multidimensional model of reality that's way more complete and coherent.
But out of all those new dimensions, there's one that is the absolute game changer. It's the one that breathes life into this hologram, giving it direction, momentum, and a sense of cause and effect. I'm talking about the flow of time. Just look at the difference here. A photo, that's just a single point in time, a snapshot. It's a what? But a video? A video is a trajectory. It's a path moving through that space. It shows you the momentum. It connects the dots. It tells a story. It doesn't just capture a what, it captures a what happened.
And that's the key right there. Time makes this entire model of reality dynamic.
The gravity between concepts isn't fixed anymore. It shifts and evolves based on the sequence of events. This is how an AI starts to understand causality. It's not just learning that A and B are related, it's learning that A causes B.
And once an AI gets a real grasp on causality, well, that's when it can start to do something truly extraordinary. It can go beyond just understanding what's happening right now and start predicting what's about to happen next.
So let's put it all together. Imagine an AI with this whole complex, multidimensional model we've been talking about hooked up to a pair of glasses. It's getting a constant live feed of reality. It's seeing what you see, hearing what you hear, and mapping it all out in real time.
What you get is one single, unified, and totally dynamic model of a person's individual reality. It's like a living hologram of their world, and it's updating itself every single second.
So here's how it works, from start to finish. The glasses capture reality as it unfolds. The AI maps this flow onto its curved multidimensional space. From there, it understands the trajectory of events, where they've come from and the momentum they have. And because it's learned the basic physics of your reality, the underlying rules of cause and effect, it can deduce the next logical step. And here's the kicker. In a model this sophisticated, the deduction is the prediction. This is the real breakthrough. The AI isn't just reacting to what's happening. It's actively anticipating what's about to happen. By understanding all the forces and trajectories at play, it can see the ball rolling down the hill and know, with incredible accuracy, exactly where it's going to end up.
And that leaves us with a pretty deep question to chew on, doesn't it? If an AI can learn the fundamental rhythm of our reality, the very physics of our daily lives, what does it actually start to understand about us? About the choices we make, the paths we take, and the future we're all walking into?